Okay, so we will start with the presentation. Um, so this is about the introduction to the Databricks platform. So first of all, what is Databricks platform? So it is a unified platform for all your data analytics and artificial intelligence needs. It allows organizations to store, process, and analyze large datasets efficiently while supporting machine learning and artificial intelligence. So before going forward to the Databricks, we will first cover what is big data, and then the introduction to Hadoop, then the switch from Hadoop to the Apache Spark, then the Databricks SQL, and then writing SQL queries. So let's start with what is big data. So big data is a data so large and complex that it becomes difficult to handle it with traditional database management systems such as RDBMS, etc. So there are some characteristics of big data because of which it is so difficult to handle them with traditional database management system. So these characteristics are these five V's of big data. So what are these five V's? So the first one is the volume. As we can say, with the exponential growth in our data, or the because of the social media platforms and then the sensors and so much increment in uh, technology, the volume or the quantity of data at present is very large. Similarly, the second one is the velocity. As I said before, the growth of data is exponential. So we can think about it with how much speed the data is being generated. So the velocity of big data is also very high. Then is the variety. So variety is the type of data or the diversity of data. You see, the data can be structured, unstructured, semi-structured, and so on. So the big data have multiple varieties. If we talk about normal DBMS systems or like tables or something, then the data in those structures is structured, right? But for the big data, this is unstructured. For example, text, video, GIFs, so much more. Then is the value of data, that is the worth of data mine. So the data that we are gathering should be of some use. And then is the veracity of data that refers to the accuracy and reliability of data. In this world, we are gathering the data from so much different sources. So the data that we are gathering should be reliable to be the big data. Then how this big data was being handled. So it started with Apache Hadoop. What is a Apache Hadoop or Hadoop? So it is an open source framework licensed under Apache, which allows us to store, manage, and parallelly process the data into a single structure. So how this Hadoop works? There are basically two components of Hadoop. HDFS, which is typically based on GFS, that is a Google file system, and another component is MapReduce. So this HDFS takes care of storing and managing the data in this Hadoop cluster, and parallelly MapReduce processes this data which was already stored in HDFS. Then how this Hadoop works? So Hadoop follows a master-slave architecture where there is a name node and multiple data nodes. So this name node is a master daemon which maintains and manages these data nodes and stores metadata. Metadata is the data about data. For example, the address of the data, the hierarchy, permission, size of the files, and etc. So this name node receives heartbeats from the data node, which suggests that the data node is alive at the current time. If it is not receiving the heartbeat, then it means that the data node is suffering from some problem, or like they are dead, or there is some issue with that. And these data nodes are basically the slave nodes, which actually stores the data where all the read and writing operation takes place. So how it actually works, let us suppose I am a client, right? So I have to do some read and write operation in the data node. So what I will do is, me being a client will interact with name node, and this name node will provide address of the data node where read or write operation is to be taken place. Then I can directly do my read or write whatsoever is required. If in case there is some issue with the data node, then it will not provide the address. So the name node will not receive any heartbeat from the data node. Then what the name node will do, it will provide address of some other data node where the replica of that same data is stored. That how this Hadoop is fault tolerant. So there were some limitations with Hadoop because of which Apache Spark became a solution for some of those limitations. So this Apache Spark supports data analysis, machine learning, graph streaming, range, etc. It can read write from a range of data types and allow development in multiple languages. As you can see here, this is the architecture of Spark where you can write SQL queries. Real-time streaming is also possible. There is a machine learning library, graph computation, and a platform for R. And these are the Apache Spark core API in different languages like R, SQL, Python, Scala, and Java. Whereas if we talk about Hadoop, so it was only limited up to Java. So there are some reasons because of which we prefer Apache Spark over Hadoop. So these are the following limitations of Hadoop or the advantages of using Apache Spark. First one is this processing speed. The Apache Spark is comparatively faster than the Hadoop MapReduce because of its in-memory structure. The data stored in Apache Spark is in memory, whereas it is not so in the case of Hadoop. Then the design of the Hadoop system is basically for the batch processing, whereas Apache Spark is more suitable for real-time data processing and iterative analysis. Apache Spark possesses a user-friendly interface as it supports various languages, whereas I told before that the Hadoop is only for the developers who can write code in Java. And Apache Spark is more fault tolerant as compared to Hadoop MapReduce HDFS. And Apache Spark has more flexible system as it can integrate with other big data tools, whereas Hadoop MapReduce cannot integrate with different big data tools, but is only designed to work with Hadoop distributed file system. Then the Databricks SQL. So before knowing what is Databricks SQL, there are some concepts that should be known that are Databricks Lakehouse platform, Unity Catalog, and then we will talk about writing queries in the Databricks SQL. So what is Databricks Lakehouse? For that, what is data warehouses? What are data lakes? And what are data lakes? This should be clear. So let's start with data warehouses. So data warehouse is just like a big library where structured data can be stored. For example, a table where the data is stored in a form of stored in organized rows and columns. And then data lake. Data lake is a big storage room where we can store different type of data. It may be structured, unstructured, semi-structured. Then Delta Lake. So Delta Lake are just the improvement of the data lake, where structure, reliability, and performance is added to the data lake. These data lakes are the basic foundations of Databricks Lakehouse. So we can say that this Databricks Lakehouse is best of both data warehouses as well as data lakes. So how does Databricks Lakehouse work? So this is the architecture of Databricks Lakehouse. What happens in it is at first ingestion of the structured, semi-structured, unstructured data takes place inside the Databricks Lakehouse. And the raw data from these is stored in Azure Data Lake Store or some other cloud-based storage platform. Then there is a layer, Delta Lake, which is built on the top of raw data layer to enhance reliability and performance. There are some features of these data lake that are they follow asset transition properties. Then they support batch processing as well as real-time streaming, and there is a schema enforcement inside it. Above this is a delta engine which process raw data into curated data. So there are multiple things that can be done inside Delta Engine, that is ETL. export, transform, and load for data engineers. You can write SQL queries inside it, which is generally for data analysts. And for the data scientists and machine learning engineers, there are machine learning libraries. And then the consumption layer, which uh, offers integrated services like BI, Power BI, machine learning platforms, etc. Then is the Unity catalog. So, what is the concept of Unity catalog? Unity Catalog is a unified governance solution for data and AI assets on the lakehouse, providing centralized access control, auditing, lineage, and data discovery capabilities across Azure Databricks Workspace. Here is a simple structure of Unity Catalog. At the top, there is a meta store, which is a top level container for metadata. It represents metadata such as the information about the object being managed by the metastore. Under this is a catalog, which is the first layer of object hierarchy used to organize our data assets. Then is the schema, which is also known as database, which is the second layer of object hierarchy that contains table, views, etc. And under these are the tables and views, which stores the actual data. So, what is the actual use of this Unity catalog? If Unity catalog is not present, then user management, metastore, access control, cluster SQL warehouses, all of this is taken care by the Databricks workspaces. But with the presence of Unity catalog, the Unity catalog will take care of user management, metastore, and access control. Whereas Databricks workspace will take care of cluster SQL warehouses only. Then we can start writing queries inside Databricks SQL. So if we are writing queries, then we will add data inside tables or views and so on. So first of all, we need to create a catalog. Then after catalog schema and inside schema tables or views. So we are not the global administrator, so we cannot create catalogs on our own, but we will start by using a default catalog and we will create schema inside it. So to create schema, we can write create schema if not exist, name of our schema, let us say demo 1. This if not exists is optional. You may or may not write it. Similarly, if we were global administrators, we could have created catalog by writing create catalog if not exist, name of the catalog. And then we can describe the schema created by writing describe schema, name of the schema, and the semicolon. Similarly, created catalog could also have been described by writing describe catalog, name of the catalog, semicolon. Then we can create table inside the schema that we have created. For that, we will write create table. This if not exist is optional. You may or may not write it. Demo 1, which is the name of our created schema, dot test 1, which is the name of the table, then the name of the columns along with the data types and separated by comma inside the parenthesis and a semicolon for representing the SQL query. Then we can insert value inside these tables. For that, we will be writing insert into name of the table, values, which are inside the parentheses. The numerical values are written without the quotation marks, whereas the string values will be written inside the quotation mark. For the different row, we will start with another parenthesis separated by a comma. And after writing the query, we will end it with a semicolon representing it as a SQL query. Then the table the values that we have inserted have three rows. So it affected three rows and inserted three rows inside the table, which is shown as the output below the query. Then we can view this table by writing select star from test one, which is the name of the table. Now, as you can see here, I haven't written semicolon after my query. So this is just because we are doing it inside a notebook where we have already written that these queries are the SQL queries. So this is an advantage of Databricks platform that if you don't write the semicolon, then even it will work. Okay, so the select star from test one means that selecting all the values from the table test one. Here I could also have written select submission number, employee name, comma salary from test one. Then are the alter table commands. So we can alter our table by renaming our table or by adding a new column to our table. So for renaming our table, we can write alter table, name of the table that is test one, rename to new name of the table that is employee demo table. And we can add our column. Let us suppose I want to add a new column, say age, with the data type and teaser to my previous table, whose name is employee demo table. So how I will be doing so by writing alter table, name of the table which is now employee demo table, add column, name of the column that is age and the data type status and teaser, and ending it by a semicolon. Then I can drop this column by writing alter table, name of the table employee demo table, drop column age, which is the name of the table, name of the column, and ending it with a semicolon. There was some issue with this code because of the version of the table properties, which I have set accordingly. This may or may not be the case with other people. Then we can delete the table. For that, we can do two things. Either we can truncate our table or we can drop our table. So, what is the basic difference between truncating the table and dropping the table? So, if we truncate our table, then the data inside the table will be lost, but the structure of table will remain as such. And if we drop our table, then the data as well as the structure of the table will be lost. Let us see by an example. So to truncate the table, we will be writing truncate table, name of the table, which is employee demo table, and a semicolon. Then if we try to view our table by writing select star from the employee table, then we will see there is no data inside the table, but only the structure of the table. That is the name of the columns along with their data types. But if we drop our table, then we will write drop table, if exist is optional, name of the table that is employee demo table. And then if we try to view our table by writing select star from name of the table that is employee demo table, then we will get an error that is table or view not found because it has deleted data as well as the structure of the table. Yeah, so thank you. That's it for today.